Consider the situation shown in figure. Show that if the blocks are displaced slightly in opposite direction and released, they will execute simple harmonic motion. Calculate the time period. Right? Now in such kind of questions, one thing you have to remember, or that is the concept point, that the center of mass will be always stationary. Fine. Or in other words, I can say that the net energy of the system will always remains constant. Fine. Now let's say if I displace this block M by a distance x this side, and this block M by a distance x this side, so the net energy of the system when the system is performing SHM can be written as total energy will be equal to half of K into 2x square. This is the spring energy because x is stretched in this direction, x is stretched in this direction, so the total stretching in the spring is 2x, and the total spring energy will be half of K 2x square plus half of mv square plus half of mv square, and that will be equal to a constant. Fine. So this equation can be simplified in the form of 2k x square plus mv square, that is equals to constant. Now what I'll do is, let's differentiate this equation with respect to t. So I have 2k into 2x dx by dt plus mass into 2v into dv by dt, that is equals to 0. Fine. So I can write 4kx dx by dt can be written as v plus m into 2v dv by dt can be written as acceleration, that is equals to 0. So I can write this velocity can be taken out as common, so v is equals to 4kx plus 2ma, that is equals to 0. I can write 4kx plus 2ma equal to 0. So acceleration comes out as 4k by 2m into x. Now again acceleration is directly proportional to x, so the coefficient of x can be compared to omega square. So omega square can be written as 2k by m, or the time period will be equal to 2 pi under root of m by 2k. That is the answer.